Yeah, thank you, Martin. So first of all, I will send the link that you can join. By clicking on the link, you can just put your name and join the game. I'm turning off the camera as Guillaume suggested for the bandwidth. And I'm going to the platform of the TORC game. Yes, I'm seeing people join. Okay, while all of you is joining, if you press the button on the right side, the lowest one, show game information, you basically can see some information about the stressor that we will play that I hope will be helpful to introduce you to the logics of the TORC digital game. So as a scene description, we have to deal with a literature water distribution network, which is C-Town. We imagine in this C-Town network all LoRa sensors and actuators connected with wireless technology to gateways with the protocol LoRaWAN. And the network, as you can see in the first image of the additional information just a bit below, you can see that it's composed by a lot of DMAs. We have 5 DMAs, 400 pipes, 400 nodes around that, 4 PRVs, 1 check valve, 1 throttle control valve, and the water is supplied to the system by a large reservoir, which is the water source that you can see in the in the right, in the lower part of the network. And we have 7 balancing water tanks. So our stressor is complaints from customers of DMA5 during peak hours. So basically what we have is that some calls reach C-Town utility because the customers of this area, of the district metered area 5, are receiving insufficient water during the peak hours. So there is a problem of pressure. Going just a bit below, you can see other images. For example, the C-Town DMAs map, where basically there is the distribution of the different DMAs. And we have the stressor at the DMA5, which is the one in red, the red color. And then also going below, you can see a control scheme of the C-Town network. Basically, almost of each DMA has its own tank. And the tank is filled by a pumping station. In our case, for example, tank 5 is filled by the pump 8 when the level of the tank is the pump is opening when the level of the tank is below 1 meter, and the pump is closing when the level of the tank is above 4 meters. And finally, you can see also animation where basically you can see the distribution of the LoRa devices in the network, where you can see, for example, pressure sensors, also flow meters at the outlet of the pump. They are connected in the center with the antenna, the LoRaWAN gateway that send the data in the cloud. So this is a first introduction of our context, and we can attribute the roles to the players. So I know that we have already a decision maker, which is Bart. So I'm putting him as decision maker, while I will ask to the others to tell me if they will be during the session an observer or a player. And if you are a player, just tell me your competencies, so we can put, for example, IT specialist rather than modeler, risk manager. It's just about a label that could be useful just to identify you. So I guess that Guillaume, Gemma are observer. We have Turulab, which role do you want to have?
I think I'm gonna stay as an observer.
Okay, observer. So we have Bart, that is decision maker, Martin, decision maker. I read Nele. or Nel?
Observer.
Okay.
Actually,
Manuel?
Camilo, of course, I am
Camilo,
also
sorry.
Yeah.
I think it's best if the people from the followers are actually players, because then they are more active in the stages of the game. Then the people that are external from the research group might be observers in that way.
Okay, perfect. So I will read through the names, and if you have followers, just tell me the role that you want to have as a player. I don't remember actually if Neil and Manuel are followers or external, so I will read everybody. So Neil is an observer because I'm external, right?
Nella is from the battle group, but if Bart is decision maker, she can also observe. I don't know. This is a decision from the battle group, let's say. What do you say, Nella?
Same for me. I mean, I'm in the R&D department, so I'm not really an IT specialist or anything like that. So I don't know if I can play another role.
I think Nelly can be a player.
Yeah. It's
just make me any player. I'll see. I'll do my best. I'll be an operator.
Operator, yes.
Something like that.
So Manuel.
Observer.
Dimitrios.
I can be an observer, Camilo, for this, to have an overview of the event.
Yeah, okay. I think also for Caro. Ali, Mackie.
You can put me up for IT.
IT, yes. Maybe I will put IT specialist. Dominic.
Well, I don't care. I take the one who is left.
Okay, I will put you as modeller.
Okay.
Sergio and Carmen.
I will be a player.
Okay. And do you have any competence in the IT, in the risk management or something other?
No, Sergio and we are not IT specialists.
Okay, so I will Sergio as an operator and Carmen as a risk manager.
Okay.
So we also need to pick one of you, just informally, that can be our note taker, because in some steps of the game we can take the notes. Actually, each of you can take the notes, maybe like a little summary of what we are discussing. But if we have somebody that is taking care of the notes, could be good. So if there are any volunteers, otherwise we can choose it. Maybe the decision maker can choose it if we don't have volunteers. It's just basically taking notes, nothing else.
So like Camilo says, everyone can make notes during the game. If you have anything you would like to just mention, or also, as Guillaume said, if you have feedback on the game. But yeah, it looks like nobody is volunteering, so I don't know, we can just... I usually start at the back of the room when picking volunteers. So at the bottom of my list of the players is Carmen. So maybe you can be the note taker.
Okay.
Okay.
But Martin, actually, we can take notes with Caro. Then the players can focus on the decisions they make. It's fine.
Yes, better.
Okay.
No worries.
Okay. So I will introduce to the awareness part now, where we will understand better our stressor and the consequences. And if we manage with the time, we have also another stressor, and we will see how much time we will take with the first one. Okay, so basically it seems that we have as players Carmen, modeller, Ali, Mackie, IT manager, Bart, decision maker, Dominic, modeller, Sergio, operator, Nele, operator. And we are finally at the awareness part. Okay, So just try to start. So first of all, let's assume that the cost of the water for the utility depends only on the lifting pump consumption. So it's just a matter of electricity. Yeah, just try to recap what we have seen. In DMA5, we have some tank and actuator involved that you can see in the reference material, also in the additional information if you click on the show game information button. So my question, just to recap, is which tank and actuator are involved in DMA5? That is the one with the stressor. You can look at the images. Any ideas of DMA5 is the one in red. We have some maps that can tell you which tank and actuator are involved.
It's T5.
Yes. And which pump we have there?
Pump 8.
Okay, exactly. Yeah, it was just to recap. So we are there with that tank and with that actuator. So basically, an engineer of the control room now have to find out why there is this, why there are these complaints. So he can look at the data of the sensor he has in the network. First of all, we have the possibility to check to some pressure meters and also to the flow meters in the pump. What would you check in the place of an engineer of the control room? First, among the sensors, flow meter, the pressure sensors.
Level sensor?
Yes, the level sensor, it could be watched and it says that it's going down. Actually, is also looking for the flow, and I can update the additional information, some of the things he say and he see. So if you click on the additional information now, you will have some more images. And basically, is seeing that in the last 24 hours, the lifted flow of pump 8, it's very higher in comparison with the business as usual behavior in the blue line. So yes, the level of the tank is going a bit down, but then there is a pump that is lifting a lot of water. So which could be the consequences? I mean, why we could have this situation? We have the complaints for the pressure in some points of DMA5.
A big leak in pipes?
Yes, exactly. So we find out that it is a big leak in the pipes, but we don't know exactly where. So you can look to the pressure meters actually, because we have several pressure meters in the network, and he finds out that at the outlet of pump 8, we have a very big drop of pressure. So you can see in the picture outlet pressure of pump 8, a very high pressure drop. So is able, in comparison with the other sensor, to recognize that the leak must be close to the outlet of the pumping station. So basically the leak is almost localized, and the utility finds out that the stressor was due to an external attack at the pumping station actually, because they can send a crew there in the pumping station, and they see that in the perimetral area of this pumping station, where the pipe goes out from the pumping house and before it goes into the terrain, there are some signs indicating some external attacks. So in this very vulnerable part. So there are fortunately other damages, and the water infiltrating the terrain just outside the station. So now we need to understand with this attack, which could be the daily economical loss we can have from this with this burst. Do you have an idea of the daily economical loss we can have with these bars?
Extra energy, but
Yes, yes, we have a problem of energy for sure. Exactly.
Loss of water.
Also,
Loss of water.
yes, there is a problem of energy and loss of water, but actually, as I stated at the beginning of the awareness phase, let's assume that the cost for the utility is just about energy and not about the water. But actually, concerning water, we can have some issue because basically we have some complaints from the customers that are not receiving the required water. So we are selling less water. So there is a problem of unsold water in a way. So we have this kind of economical loss, the electricity, as I think Carmen said, and also this unsold water. So concerning electricity, we need to figure out how we can assess how much electricity we are consuming now after the stressor. So I put here in the additional information, just in the bottom, another images, but basically there are some writings that are basically they say that we have the source 15 meters higher than the pumping station. So the pressure at the outlet of our pumping station is given by this 15 meters of elevation more of the source, and of course the rest is given electrically by the pumps. So since we have a pressure meter and we know the pressure P, it is possible to compute the head given electrically by the pumps by subtracting to the pressure the elevation 15 meters. And this data, we have it because we have the outlet pressure of pump 8 and we can understand which is the head given electrically by the pumps. So now that we have this data, the pressure and also the head given by the pumps, we could be able to compute the energy. And we have the data before and after the stressor. So I think that now we are ready to, and I will ask now to do some computation and recognize how you can manage to calculate this electricity, the additional electricity, but also there is something to do with the unsold water. So I would suggest to the note taker to write some notes about what we have discovered, and then I will let you do some computation about how to understand the impact.
Okay, Camilo, but if I make any mistake, correct me, because I am collecting some information, but maybe I've missed something.
Yes, of course. I'm looking at your notes. If you want, you can also share what you think and what you are writing in the meantime. Okay, yes, was a discussion on the actual criticality. Facilitator is showing information. Yes, which seems higher than business as usual. The outlet pressure of pump 8 also shows a pressure drop. The players attribute this to a possible leak in DMA5, for instance, to a damage. Yes. In the perimeter of the pumping station, there are also some signs of external attack. That's true. The losses are the loss of water and extra energy, and the facilitator provides mathematical data to assess the daily consumption for the two scenarios. That's right. Just a little clarification. When in the last sentence you say the losses are then loss of water and extra energy, actually the loss of water is not a cost, but what is a cost, an hidden cost, is the unsold water, because of the complaints of the customers, we are selling less water. So maybe I would write not loss of water, but unsold water.
Feel free to correct it, Camilo, yes. It's mostly customer minutes lost, mostly. Or the water doesn't have a price for that interval.
If you like this, that's fine. Absolutely. Okay, I would say it's good. So now in the impact assessment, you should be able to see with the button resource cards some tools we can use, but also you can add some tool you want, and you have something in your reference material that could be useful. I mean, you can use in this case both one external tool and one of the cards. Just talk among you and just try to figure out what you can use. Do you have any ideas? The decision maker has an idea about which tool he can use as external tool and also as resource card.
Are there any of these tools that you don't know about, that you need more information about?
These are the same tools that you've been exposed in the previous training events, let's say.
Yes.
Yes, consider also that you can use some external tool using maybe the reference material I gave you. Because basically to assess the impact now of this stressor, we need to compute the additional electricity that is a cost for the water distribution network. And also the other thing we need to compute with one of these tools is the unsold water.
Maybe it's just too easy, but it should be Excel.
Yes, it is. But now you have to compute it. So maybe by using the formula. If you want to make it more interactive, you can also say what you are seeing, and if I don't know if you are opening the Excel file. If some of you has the Excel file open, you can also share the screen so we can just see the computations.
I can share my screen.
Okay.
I'm not sure if I did it right.
Okay, perfect. Let's see it. Yes, so basically you have multiplied H pumps with Q pumped for the specific weight of water and divided by the efficiency. Yes, yes, maybe we need just to convert because we have liters per second and we want cubic meters per second, so we need to divide per 1000, and also we want kilowatt hours. So right now we have watt hours because each time step is 1 hour. So we need to divide for 1 million because yes, perfect. Exactly. Okay, so basically in the bottom, in the yellow lines, we can see actually, yeah, perfect. So
And this is the difference.
yes, so we have around 200 kilowatt hours of difference every day. And if we assume that we have a cost in the C-Town water distribution network of, for example, let's say 20 cents of euro per kilowatt hours, so we can understand what is the amount of the loss economically. Yes, it's around 40 euro daily. That monthly it means, yeah, assuming 30 days, yes, 1,200 euro. Yes. Exactly. So this is the cost that we can have because of this burst. That will be noted down, but that's perfect. As I told you, there is also some other things to assess. We can assess the impact of the unsold water by using one of the tools we have in the resource cards. And if you don't remember well,
Avat?
no, because AVAT is about the vulnerability, not about a pressure-driven model that can help to compute the unmet demand. Yeah, I saw something.
Disable physical threats stress platform.
It is. Yeah, it is. It could be a good idea because basically the key performance indicator of this tool of the Stop It project, we have the number of customer experiencing insufficient service and also the amount of the unmet demand. So it could be used to explore this. So unfortunately, you cannot run it because you need the software to do it. But what I can do is just running for you the tool, and I can add maybe in the additional information the results.
To let you understand, this tool was the tool that we saw in the training events of Profile 2. It was back, was really the event in December of 2019, Martin, if I'm not mistaken. And this was the STP framework along with the KPI tool when you had the access to the Stop It VM.
Yeah, I don't remember it because I wasn't there, but probably yes.
The followers should have some, you know, memories from it, at least, I hope.
I don't think that the other resources are effective in this case.
Yeah, that's true. So now I'm putting as additional information new images that comes from the results of the software right, that is this second card. And now you can see some of the results I had by running it. So basically I put just outside the pumping station at the entrance of the MA5 a certain emitter coefficient that can give me the flow that we saw in the data of before that we checked like with the engineer of the control room, and at the same time the pressure that we had observed. So basically, if you see the images and the additional information at the bottom, there is the parameters we are looking for. Because in the table, we have the unmet demand, if you can see it. And it's true that the impact is also about an issue with the reputation, because we have several customers experiencing insufficient service. Probably it's more complex to compute on a economical level the amount of money that this implies. But still we have the unmet demand. And for example, if we assume that the Seatown utility is selling water like €1 for each cubic meter, we can actually compute it, compute the monthly cost, because the unmet demand that you are seeing in the right is about a daily simulation. So can you see the pictures?
Yes.
Okay, so basically you can now understand the amount of money we are not, I mean, there is this lack of water service, so we are not selling that amount of water written there every day.
So is it 64,000 liters or?
Yeah, it is, exactly. Okay. Because basically it's the unmet demand. It's one of the 5 key performance indicator of the right.
Okay, so 64 cubes times the 20 cents per cube that we said earlier. That's,
yeah, we have.
And this times 30 days.
Exactly.
That's €384.
So if I understood well, you did. You have 64 cubic meters, and you multiplied for 30 days, right?
30 days, yes.
Okay.
And
so
20 cents per cube.
I think it will be around €2,000.
Okay, maybe someone else calculated because I get around 400.
I'm just checking. I'm just multiplying 64 per 30 days. Yes, it seems it is €1,920.
No, that's in cube.
You can't multiply by 20 cents because the 20 cents was the price per kilowatt hour electricity.
Exactly.
Okay. Yeah.
Yeah. It's another unit cost.
Yeah, I wrote it wrongly in my Excel.
Yeah. We have the cost of the additional energy for pumping more water, and has a cost 20 cents per kilowatt hours. But then there is the other unit cost that is €1 per cubic meters. So if it is €1 and we have 64 cubic meters per day, in a month we have, I computed now, €1,920.
Okay.
So basically, the note taker, I think, can add this information in the notes by saying that we kind of recognize which tool we can use to compute and the amount of these problems. So there is like an impact assessment in terms of euros. Okay, thank you. The facilitator reveals a number of resources. The players seem to have basic knowledge. Spreadsheet, yes. Yeah, thank you for citing AVAT and then the stress testing platform. Exactly. Yes, so basically we know that our stressor is provoking around 3,000 euro per month. So now that we know these impacts, we can move forward to the anticipated and sense making, trying to choose some options to prevent in the future this from happening, because now we would like to find some measure that could be useful in reducing the risk if the stressor will happen in the future, by preventing it, mitigating the consequences, and so on. So if you click at the button with the risk reduction measure card, all of you can see all the possible measures. You can discuss it, and I think just the decision maker can select it. Then each of these measures that you select will be discussed in the next step, that is the feasibility evaluation, and we will try to understand the cost benefit for each of these possible solutions. Do you have any ideas of measures? I would suggest to pick up to 3 choices, so we will not have a very long feasibility evaluation. I think that 3 measures could be enough then to evaluate it. So if any of you has some suggestion, just say it. Otherwise, the decision maker can pick at least a couple of solutions it wants to implement.
I would put pressure and flow sensors in place. That's measurement 20.
Okay, yes. So, okay, perfect. Then it will be part of the feasibility evaluation.
And how about one of the first 4? Because I think you said that it was obvious that it was some malicious, I don't know, attack, or that it was made on purpose or so.
Yes, exactly.
So fences and walls.
Okay. Yeah, you can select it. Yeah, I mean, you can select also a couple of others. I mean, just something that makes sense for this kind of attack.
Could also choose camera surveillance, but it's similar to fences and walls, kind of.
Automated valve control.
Okay, you can select it. Now we will discuss it then in the next step. Okay.
How about the M25 operating parameter surveillance?
Yes, perfect.
For employee trainings.
Yeah, yes. You can select this, and then I will say to stop, because otherwise we will have a very long feasibility evaluation.
Okay.
Okay, so now we have some ideas to how to deal with this problem, and just keep in mind that we have also the impact, so we can also try to understand among this solution which could be feasible, because we have a damage of around 3,000 euro per month. So if I move forward, then by clicking on the button Evaluate Feasibility, there is the possibility to start the evaluation for each of the cards in terms of cost, benefits, and also human resources. there is this distinction because there is, yes, the cost, but then since the human resources sometimes are very high costs when it comes to, for example, hiring new people, then financially is a big cost, so we decide also to separate it. Then, of course, if you put more dollars in the cost, it will be more expensive. More stars in the benefit will be more beneficial. More men in the human resources will be more expensive in terms of human resources. So first of all, I see the pressure and flow sensors M20.
I think it will cost a lot of money. The benefits will be high. And
okay, can you motivate why the benefits can be high?
Because if there is a loss of water and you have enough sensors, you will be able to pinpoint the location of the leakage much sooner.
Yeah, that's correct. That's correct. So yes. And about the cost, because if you put a lot of pressure and flow sensor, depends on the amount, it can cost a lot.
It will cost a lot. I would say $4 or something like that.
Yeah, I think it's reasonable. Yeah, you can also put a description, I think, in the cost. Basically, it costs a lot because we need to put a lot of sensors if we want to have this goal of recognizing the area. While the benefit could be good because then you are saying, okay, it's true that we have 3,000 euro per month, but if we understand very quickly where we have the leakage, we can just go there immediately. In terms of human resources,
I think it won't be so high if the people are well trained.
yeah, because basically you need to install it. Yes, then a little of yeah, you can just see all over the time if they are working, but actually it's more one-shot event when you are installing that.
Mm-hmm.
Okay. So we can do the same with fences and walls, but consider that there is this pumping station and the pipe goes out from the pumping house, and before it goes into the terrain there is this problem. So there is already a sort of fence and walls, but there is this vulnerable part which is being attacked.
If the vulnerable part is not so big,
exactly, that's what I meant.
It won't cost so much.
Exactly, that was what I meant.
The benefits will be high.
Yeah, for sure. You are imagining to protect all around this vulnerable part.
And the human resources will also be relatively low because, again, it's a one shot.
Yeah, that's true. Yes, camera surveillance.
High cost.
In terms of what?
A camera costs a lot of money for buying and placing.
Yes, if you read the scope of use, it's written that intruders are detected by the staff that is surveilling the monitors. So it seems that here the human resource could be relevant.
So the cost something like that. Benefits high, but the human resources are high.
Exactly, yes. Yeah, because if you want a continuous control, you need some stuff continuous checking at the cameras. Okay, somebody suggested automated valve control, so I would like to understand why this choice.
So you can act quicker to isolate the pipe with the leak.
Yes, so you are referring to when it comes when, for example, you want to repair the leak. Then, if you have an automated valve control, you can do it faster. That's what you mean?
Yes, and to supply these affected people in another way with another pipes. You can open and close some valves, and so you can supply these people.
So you are imagining an automated valve controls also in terms of a redundant infrastructure that can be that maybe could be a parallel pipe in those
yes.
this vulnerable part.
Mm.
Okay, so we can just describe better when it comes to the cost and the benefits by stating that this automated valve control include also redundant infrastructure, but it's true that there is also amongst the measure another card that is a redundant asset. So probably, yes, we can write automated valve control with some description of redundant asset, but actually there is, I think, another card amongst the risk reduction measure, which is the reduction measure. For example, if I move backward, you should see it. Can you see the risk reduction measures?
Yes.
Okay, I think there is, yes, M30, there is redundant assets and infrastructures. Maybe it's more related. So probably we can convert this automated valve control with redundant asset, I would say.
No, this one.
Sorry?
Yes.
The distribution network that is applied by the 5 tank is connected with another distribution network. or is isolated?
No, basically, if you see the topology in the additional information, the water is coming just through one place. So basically, the water always passes through the pumping station where you have pump 8. Yes, you have the tank 5 that is collecting water, and sometimes it's supplying, but the source it's always from one direction.
Yes, but if the distribution network is connected with another distribution network with more pressure, these automatic valves can open and control the pressure that you supply at the sector of is cut by the leak. So yeah. You can supply the customers if you have a leak, you can continue with the supply with another sector that have more pressure.
Yeah, absolutely. So we can also intend this redundant asset like another pipe from another water distribution network, but maybe this water distribution network is not so close, so maybe you have to add a very long pipeline, so we can estimate a cost which will not be probably so low, but the benefit could be very higher because you don't have any more unsold water, but at the same time maybe you will have some electricity issue still, because if you don't have also the automated valve that is closing the pump 8, you are still running the pump until.
Okay.
So yes, it can be selected, but then it comes to the feasibility evaluation. So if we go in the feasibility again, we should see what we have, yes, written before. We can. Yes, so redundant assets and infrastructure. I mean, because of this discussion, I would say it will be expensive. And just to figure out the benefits, because it's true that now you will have the pressure for the customers, not anymore unsold water. But it's also true that with just this option, you are not reducing the lifted water from the pump 8 that is pumping probably a lot. Yeah, and also here is about not so much in terms of human resources, because it's one-shot operation and then some maintenance, but mostly at the beginning. Okay. Who picked this operating parameter surveillance and why? I don't remember who picked this operating parameter surveillance. Maybe if you can explain why, in which sense.
How better you are looking at your operating parameters, how faster you will detect that there is something wrong and how faster you will be able to stop the leak. I think.
Yes. And Which cost do you think it will have?
Only human resources.
Yes, because you are seeing that it's about just seeing the data, the flow of data.
I haven't chosen this measurement, but I think if you see it together with the training of the people, I think the cost is very low, the benefits are relatively high, and the human resources are also high.
Yeah, I agree.
I don't remember, maybe I picked this one, but I'm wondering, we calculated the costs with the 30 days. Is this because it was already 30 days going on before we detected it, or because we know it will take 30 days to detect it and to fix the problem?
No, because it can give more sense, probably, because then now we are trying to understand which measure we want to implement, also reducing the time. So we have just a month horizon of this possible cost, 3,000 euro. But then, of course, if you have, if you can implement the measure the day after, it's better. After 20 days, it's okay. After 3 months, not that good. But of course, it depends also on the protection you can implement.
Yeah, because to detect it quickly is one thing, but then to fix the problem quickly is maybe also not so easy. It depends on the availability of human resources, I suppose. But I agree with the stars, etc., given here. So
yeah, yeah. So these employees trainings, I think it comes with the last option.
Yeah, I think the better your employees are trained, the better they can do their work, and the faster they will see that there is something wrong. The faster they can make the right analysis, what is the cause of it, and what they can do to take the problem away.
Yes, that's correct.
I think it doesn't cost so much. I think the benefits are very high.
Yeah.
And the human resources are not so high.
Yeah, that's true. Probably it should be then associated also in terms of cost with the last option. But yes, like considering a single measure, it isn't that expensive. Okay, so it seems we finished the feasibility evaluation. And now if we move forward to the decision step, by clicking on the hammer and clicking also each of the measure we analyzed, we can have a quick look on the cost-benefit analysis, trying to understand which measure we want to pick, and also we can pick more measures. I mean, also, for example, a couple of measures if they go together.
fences and walls and camera and surveillance are going together.
Yeah, you can also pick just, I mean, you can discuss it because it then depends on how much money you can spend. You can also say, okay, it's not that big issue around that part of pipe because it's 3,000 euro per month. So maybe I don't need to spend that amount of money, or you can say, yes, it's worth it.
So what do we do?
So basically, yes, there is this possibility of picking these solutions together, but then you have to compare it also with other solutions. You said, for example, employees training with redundant assets and infrastructure. Maybe you can compare cost and benefits, and this can help to choose.
Pressure and flow sensors and redundant assets and infrastructure, operating parameter surveillance and employee trainings are all necessary or none is necessary in my point of view.
Yeah, so in your opinion, they go together.
Yeah.
So if you, in a certain sense, you can consider the total cost as the sum of these measures.
I think so.
And then you can compare with the sum of the other cost you have with the other, the same for the benefits. Okay, yes, perfect. Yes, so basically we can end the game. Yes, and I'm adding the general recommendation I just said. And probably now you can see this screen where you can generate the game report at the bottom of the page. And basically in the game report, it is written what we say during the game, what we have said. You can download it and it's like a PDF file. If you open the PDF file, you will see, yes, the players and then the action agreed, the risk reduction measure selected and then chosen after the feasibility evaluation with all the details and the notes. Can you see the report?
Yes.
Okay, so basically that was the first session. If